Hello, everybody. Welcome to the live stream today. I am David Jones-Gilardi, Developer Relations Engineer, and I'm joined once again by Rodrigo Nader. Hi, Rodrigo.
Hello, David. Nice to meet you again on a live stream.
Yes.
So
Yeah,
second one.
I feel like we keep doing this. Like
I think
somehow
so.
we just keep ending up on these live streams, having these conversations. Hi there, John and Naman, and oh hey, Misbah. We got Misbah here today. So
Okay.
if you would, everybody in the chat, let us know where you're from, things like that. What are you working on? That kind of deal. But I should mention that Rodrigo is one of the co-founders of Langflow, and we will actually see a little bit of Langflow today. And by the way, there's a construction truck outside, so I hope that the beeping isn't too terribly loud.
It's okay. It's very low. It's very quiet.
Okay, good, good, good. All right,
Good,
yeah, I
good.
see we have some folks from Norway and Sweden. Awesome, from Los Angeles. Hey there, Rahan. I used to live in the South Bay in Hermosa
700
Beach
folks
over there.
subscribe. Okay. We have a lot of people joining. All right. That's cool. That's
From
cool.
India, wonderful.
São Paulo,
Okay,
love Brazil.
Canada, Argentina. Oh, hey, look, there's someone from Brazil there, Rodrigo. Excellent.
Oh, yeah.
Awesome. All right. Well, with that, everybody, so let's go ahead and get started. A couple of housekeeping items as we get going. So here in our system Crowdcast, we do ask that when, we expect this to be interactive, right? Rodrigo and I are going to have a conversation. We're going to be talking about text splitting and RAG and things like that. But, if you have thoughts and questions and that kind of deal, feel free to ask them. You'll notice that there is a little widget usually to either the right side or the bottom for Q&A. So we do ask that if you have a question, put it in the Q&A. That way it gives others an opportunity to kind of upvote it, right? We can kind of put it all in one place and such like that. But if you want to have general conversation, feel free to do that in the chat. So, Rodrigo, all right. So, what,
Oh,
a couple weeks ago? Was it a few weeks ago now? We had a
yeah, 2 weeks.
conversation, right? We had a conversation about, kind of going beyond basic RAG.
Yeah.
And we should probably set up a little bit with what RAG is, but
Mhm.
then give a little bit of a review of what we kind of went over last session. And then
Yeah.
today, what is it that we're going to jump into?
Yeah. Okay, cool. I think, well, we have text splitting, right? We have a new
Yeah.
article that came through. We just released that today. So go ahead and look. I think there is a button over there. You can click text splitting if you want to take a look at the article already. And we're going to talk a little bit about text splitting. We're going to show, maybe if possible, do some demos over here. And we have fun, interactive ways to explore like text splitting techniques. So with that, I think, David, should I share my screen?
Yeah, let's go ahead and do it. That way we can give just a quick little review, of some of the methods that we went over last week.
Yeah. You know what? You wanna start with what is RAG again, to set the stage and everyone be on the same page, and especially maybe not only what is RAG, but why? Why do we insist on using RAG? Why is it so important? Models are getting more and more like longer contexts, right?
Yeah.
We're getting stuff like prompt caching. We also have an article about prompt caching. So if that's the case, do I still need RAG for my application? Yes or no? That's a nice conversation. So maybe a quick tour around why RAG. What you think?
Yeah, let's do it. Matter of fact, I do see a comment here. There we go. Thank you, Misbah. I saw that. Yeah, I saw Ryan was saying the video is still loading. If you do have any kind of challenge with your video, or if it's kind of blurry or something, just reload your tab. Usually that clears it up. But to your point, Rodrigo, to kind of give a little bit of a primer on RAG and why it's important, right? Because you made a really interesting point there. And this has come up time and time again recently at a lot of conferences and events and things that I've been doing personally, where people are like, hey, like the context windows for the LLMs are getting really, really, really big. Do I even
Yes,
need RAG? What's the point at this point?
exactly.
But
Yeah.
there are still plenty of reasons why you should. And let's rewind that a little bit, talk a little bit about what RAG is, right? So RAG means Retrieval Augmented Generation. So what are we doing? In a RAG pipeline, you're going to retrieve data, right? Contextually relevant data, probably from a vector store. That's kind of like the way that we do it, right? You're going to use that to augment the context of the LLM. So if you didn't know this already, like when you're talking to like ChatGPT or something like that, you can give it a prompt, right? You can give it instructions. And one of those things you can do in a prompt is you can give it context. So you can say, hey, I want you to use this context and then answer a question or do something with it, right? And
Exactly.
so
Yeah.
in a RAG pipeline, you're going to retrieve data from like some store. You're going to pull that back. You're going to use that to then augment the context of the LLM to then modify its generation, right? And so it's a way, essentially, you can kind of make the LLM smart on a topic that maybe you didn't have information about, right?
Exactly. Exactly. You're grounding the answer that you want the model to give, right? You're
Right.
indirectly via a prompt, you're influencing the output of the model by passing some more information through the input, right? And this more information you're getting from your knowledge base or the data that you need to extract from, right? And this data
Right.
could be a book, it could be a corpus, a corpora, it could be like huge tons of data files that you scanned and became digital data, right?
Right.
So depending of what you want to do, RAG will be always important, and I'm gonna try to tell you why, right? So if
Yeah.
with longer, let me share my screen and let's start from the allow to share screen. All right. So can you see this? Can you see this
I can see
article
it.
over here?
Yeah. Hopefully, everybody else is
All right.
seeing that retrieval waiting blog post as well. If you can, give us a little thumbs up. Let us know that you're good to go. And matter of fact, we will drop the links for those. I think Michelle did a little earlier, but we'll drop the link for this. Now, this is the one from before, right? This is the one we're going to review real quick. We did this one a couple weeks ago.
Yeah, so we actually did two a couple weeks ago, right? The number one was retrieval. Actually, the number one was similarity versus relevance, right?
Yeah.
What is relevance in RAG, and what is similarity, and how similarity is used as a proxy for relevance in most of the cases, right? I like this image because it gives you like the simplest RAG system you can ever get, right? So you have a query or a customer's or a user question, right? And you have your data divided into chunks or parts of texts, right? And you have a lot of chunks that you don't know if they are related to the original query or not. So let's say my question here is, who's Harry, right? I'm looking at Harry Potter's book, right? And I have a lot of chunks, meaning in this case, sentences inside of the book. So I solemnly swear it. It's Leviosa, not Leviosa. You're a wizard, Harry, right? So these are the three sentences that I have opened over here. Like let's say I have these three sentences at disposal. Which one is more relevant to the original query? That's what
Mhm.
this article covers, and it's trying to tell you that there are multiple ways that you can try to address the problem of figuring out what relevance is, right? But in a very basic summary, the idea is that relevance is the probability that a piece of text contains enough information to answer the query, right?
Right.
Basically, how can I know that, right? Because if I'm not using a model, if I want to use like an efficient approach, especially, right? How can I know which one of these are more similar or better, more relevant to the query, right? And here I'm using a keyword approach. I'm just saying, hey, just look for stuff that has one of these words, either who or Harry, right? And it
Mhm.
found one of them with Harry, and I said, okay, if you contain a word that is present in my original query, right? Maybe you are sort of relevant, so I'm going to consider you as a relevant check, right? And then similarity takes a different approach, which is, hey, if the vector that represents this sentence is similar or has a spatial distance that is small to the vector that represents that distance, we're
Mhm.
saying it's more relevant. And then you have a lot of approaches to define and explore like different ways to measure what relevance is. This is what this article is about. But then you go back to the question, so why? So before anything, I'm showing you chunks, right? And today we were talking about chunking or splitting, right? So why do I need to do this at all, right? So we
Mhm.
come back, I think, to the text splitting idea as a whole, and again to the topic of why do I, so before anything, why do I even want to split? Why do I even want to feed a vector store and not directly retrieve? And these are the most reasonable like arguments I think you can think about. Number one, you have a finite context size, right? So models have a maximum input size. What that means is that, yeah, there are longer and longer context sizes, but still models are very limited in the capability of, yes, I can handle like books and more books as context. No, typically models are limited in that there's a hard constraint, right? And then the second is, even for models that have longer and longer contexts, you're going to find that the accuracy starts decreasing when you
Right
have
there.
a longer context, right? Does that make sense?
Yes. And actually to that, I want to just interject for a moment. This actually gets back
Yep.
to the original question. I think we started to address this in the very beginning, but the one that's come up a lot is like, okay, so the context window size for a lot of the LLMs has gotten huge.
Yep.
Why does RAG still matter? Or something like that, right? And what you're getting at
Yep.
right there, I think is key, is that you can have all the, if imagine for a moment that the context window is essentially infinite, right? You can put whatever you want into the context window. Well, okay, so right there, if you're asking a specific question, going back to the example you just gave a minute ago there, Rodrigo, with that
Mhm.
diagram, if you're asking a specific question about like Harry Potter or something like that, but you throw, you know, every bit of information that you have at the LLM. Well, for one, you're paying for that, right? You're going to pay for all those
Yeah.
tokens. Two, now the LLM still has to process through all of that data and find the relevant bits. And then three, you're not really giving it at that point the relevant information, right? It's actually cheaper and more efficient to store data like that in a database. Databases were made for this, right? And
Yes.
to leverage them to then retrieve just the relevant parts that you can give to the LLM, and then you're paying less for tokens. Like you're allowing the LLM to process on it faster, things like that, right? So even in a case where you have unlimited tokens, right? Just pretend, or unlimited context window or something like
Yeah.
that, it's still RAG, it's still relevant. I think it's funny saying that because it's all about relevancy, right? But
And it's more,
very
than
relevant.
that, right? Yeah, I completely agree with that. And there is even another argument, which is, all right, let's say we have infinite context sizes, right?
Yeah.
All right, you're gonna trust your model to do the retrieval. It's not retrieval, right? The model is doing everything at once. It's answering and it's retrieving and answering at once, but you're trusting the model to do that. What that means is that you are relying on a sort of a black box, right? Today, the
Mm.
machine learning models, and especially large language models, regardless if they are from a provider or not, if they are a provider, even more, right? But if you're using the model locally, they are still black boxes because of their
Yeah.
complexity, right? They are too big, too long, too complex for you to get deeper into these models and understand. This area, like understanding and interpretability of models, is growing, but very, very far from fully understanding, or if ever, we will be tweaking the nuances inside of the models. I don't think so. I think we got to a state where we said, hey, it's okay to have a black box, which are these long, complex, and very, very advanced models. And we can tune like the inputs to manage the output. We can tweak the inputs
Right.
to improve the answers we want to get. So that means less control. If you're trusting the model for everything, you're saying, I don't have control of any step of
Mm-hmm.
the process. If you say, hey, I'm gonna create a RAG system, it means I'm gonna feed information to this model in a way that I can control what goes into that, right?
Right.
And I can put hard guardrails, I can wait, I can do a lot of rule-based processes in the middle of the way that are gonna help me maintain the behavior of this model in a way I can't do if I just trust the model to do, right? So even if
Got you.
infinite with infinite context size, I'd say RAG came to stay. It won't go away, right?
Yeah.
The problem that you raise about cost, this one is, every time you're running the model again and again and again through the same prompt or the same context, right? It's going to spend, and it's expensive, right? Models are expensive because they are so heavy. So this is another very important point. There is a counter argument over there that we can get into if you want
Prompt
to read a
caching. I
little
was
bit.
gonna, yeah, I was gonna
Prompt
bring that up. We
caching,
talked about it last
yes,
time, right? Yeah,
exactly.
yeah,
Yeah, and this is not the prompt caching, just the prompt caching that you see out there on OpenAI prompt caching and Anthropic Cloud's prompt caching. This is looking at the most advanced papers on prompt caching. I'm trying to give an overall over here. Suggest you go into the papers if you want, but this is explaining how the cost is going to decrease by huge amounts very, very soon. And this is
right,
huge. I think if you ask me what is going to be the future of this kind of thing, it's probably going to be something hybrid. It's a RAG system that where the model has direct access to the database or something like that, right? But for now and for the next good years, we're going to stick with RAG. It's going to be important. We don't have a way out of it. That's what we want, right?
yeah.
And okay, so for RAG, we need to split our content. What does that mean? It means that we need to decide what chunks or what parts of our data we want to retrieve so that the model is going to be contextualized, right, with that content. And how do we bring just content that is relevant? We do that by finding parts that match what we need, right? So I'm asking a question: who's Harry? I want to find parts that are relevant over there. And to find parts that are relevant, first I need to have parts, right? So I want to split my content in a meaningful way so that then I can retrieve those meaningful parts and feed the model. Okay, so this is what splitting is made for, right? And we know, and I'm gonna bet most of the folks over here already know that there are multiple different ways that you can split text, right? Obviously, right? You can split when you say split text, we're talking about literally the process of splitting, right? We are hosting a live stream over here, period. It's Rodrigo and David, period. Let's split by every 10 words, or let's split at every period, right? That's what we're talking about. We're talking about splitting the text documents into smaller parts, right? That's only that. There are rule-based systems, there are machine learning approaches, and simpler and complex ideas over here. So starting with character-based splitting, David,
You know, Rodrigo,
you wanna go
before
through and yeah,
before you go through the individual splitters and that kind of deal, um,
okay,
I think we should maybe explain like why. I think this gets into the same like why are we splitting, right? You were talking a little bit
okay,
about that, but I mean, I'm looking at it more from a standpoint of, is it similar to what we were just talking about a second ago with regard to, even if you had an unlimited context window or something like that. Going back to the Harry Potter example, right? Let's say we took one of the Harry Potter books, and if we didn't have any splitting at all, and we again had unlimited context windows, you'd essentially just be taking like the whole of the book and throwing at the
yeah,
LLM and then saying go find this one thing, right? So
yes,
is the purpose, I from what I understand, like a lot of the text splitting stuff came into play because there were original limits, like there were much tighter, narrower constraints on the context windows originally when these LLMs really kind of first went to the market and everything. And so you kind of had to narrow down the amount of characters you were sending to them. But now that's less and less relevant, right? Because these context windows have gotten so big. So my question to you
yeah.
is, I'm kind of like I'm setting you up here. My question to
No,
you
no, this
is
is
like
so
again,
let's
why do we need to do splitting now,
okay.
even in the times of these big context windows?
Yeah, so let's imagine the situation where we don't do splitting at all,
Okay.
right? It means every time I'm running the model, I'm asking a question about my book. Let's use a book throughout this entire live stream, right? As an example, you can have much more data than a book, but let's use a book
Right.
as an example. So I'm asking a question and I want the answer, and the answer is within that book, right? As it's very inefficient to have a model reading everything again and again and again at every question I make, right?
Right.
It's like I'm asking you something about a book. First, you're probably, if you're going to try to address that question, you're probably going to go through the book and you're going to try to find first maybe chapters that you think the answer might be in, right? And then you're gonna nail down into maybe pages, right? Where you say, oh, there are some stuff over here that may be related with what Rodrigo is asking me, right? And only then you're gonna try to find the answer and give me. Why? Because reading the entire book just to try to give me an answer is it's a completely waste of time
Mm.
and resources, right?
Right,
So
right,
this is why we don't want just one chunk of big chunk of information, because that means we need to go back there and read that entire chunk every time, right? And how annoying that is for our pockets in terms of cost, how annoying that is in terms of time for the
right.
models to read and so on. It's inefficient, right? So what is much more efficient than that is, instead of having one book, is if I had every page, or better, every sentence separated into, let's say I have sentence level splitting, and inside like paragraphs I have sentences, inside pages I have paragraphs, inside chapters I have pages, right? So I'm gonna have the entire information structured so that a system, when it's trying to find information, does a very quick retrieval process, right? It
Mm.
looks into parts that are most similar, and it maybe digs into that information quickly, retrieves only what's necessary, and comes back with that information. Does that
Got
make
you.
sense?
Yep. No, that definitely makes sense.
Okay.
Thank you for going over that. I want to make sure everybody was kind of on the same page as well. And I wanted to pick your brain as well to see what you thought about that. So,
So I think that's one of the reasons, right? And we can probably think about others, and you start understanding how the process of how the attention of the model, of these language models, are very useful in this sense as well, right? If you think, this is sort of what these models are doing within their architecture itself, right? They're trying to use, when you give a lot of context, they're trying to find like important parts automatically, right?
mm,
But they are very, very heavy because they are doing so many things inside of them. They have so many parameters and so on. And what we're trying to do here is, how can we create a process that is super efficient, right? To retrieve just the most important parts, and how can we split or chunkinize our data so that it's stored in a very efficient and meaningful way, so that
okay.
when models want to retrieve, it makes sense, right?
Yeah. Okay.
Okay. So cool. So from this point, 1 second.
You know, I've got mine
Most
as
important part.
well. We
That's the
should have
most
timed
important
that,
part.
right? No, time our espressos.
So from this point, you start thinking of, all right, let me take my text and my book, and let me split it before I store it. And by store it, we also mean vectorize it, right? And a vector store, you're typically, so you split your text, and then you're gonna feed those chunks that you created into vectors, and these vectors are what carry the representative meaning of your chunks, right,
Right.
for retrieval. So multiple ways that you can split text. You can be very, very basic with character-based splitting, right? This is the simplest way you can split your text ever. Well, let's split every time there is a period, or every time there is a comma, right? Let's split by, I don't know, every 10 characters or something like that. So rule-based, super simple splitting. Questions?
Oh, as a matter of fact, there is one. Funny, I was going to type it, but since you prompted me, I'll just go ahead and do it. One from Zahara. Hello, Zahara. The question is, can you recommend a template or structure for splitting, chunking text for the use case of PDF documents that might have tables and images as well? And yeah, actually, I'll give an answer there, and maybe Rodrigo has some feelings. There are actually tools out there today. Unstructured.io is the first one that comes to mind,
Yeah.
that is geared specifically
You
towards
open
this
it up.
exact. Are you going to pull something up like that? Yeah, that's geared
Yeah.
towards this exact type of need, where it will intelligently go through something like a PDF and pull out the pieces that are actually relevant. You can decide whether or not you want to include images or not, and things like that, and give you more control over that, because that's exactly what, funny enough, what Unstructured is about. I should actually plug that both Langflow and a DataStax Astra, vector database do have support, inherent support or direct support for unstructured. So if you're looking to bring in like a PDF or something like that, you can actually just use it. You can also just use the LangChain unstructured libraries. Like there's a bunch of support for types of things like that. But my response there, Zahara, would be to go to someone like an unstructured.io that specializes in pulling up relevant contextual information from something like a PDF, so you don't get all the junk, right? Same thing with like HTML pages, web pages, right? They have lots of extra stuff that if you were to just pull the page content is it's not relevant at all, right? So anyway, that's my take on it. Rodrigo, do you have any thoughts there?
Yeah, 100%, 100%. I completely agree. So the idea here is you have a PDF, and then inside of your PDF you have text, yes, but you also have like tables, you have images, you have stuff like maybe titles and bullet points and stuff that you want to structure, right? Instead of just extracting the raw thing. And tools like unstructured.io are made for this. We have a component in Langflow. We just released Langflow 1.0.19. And it has an unstructured IO component. So if you want to check that out, go ahead and look at it. So the idea here is that you're gonna have positional, like you're gonna have the text splitted and vectorized, but then you're gonna have images extracted as well, and you can, for example, convert these images if you don't want to use them and you want to use these images as just a placeholder. You want to add a placeholder text for images, for example, right, or for tables and so on. So this is, I think this is the idea. You have pre-processing, splitting, and structuring libraries out there exactly for that kind of task, right? So,
exactly.
but that is much more than just character-based splitting, right? So,
yeah,
character
that's a lot more advanced. Yeah,
yes, yeah, and character-based is like, all right, I just want to do a rough splitting. I know my data. I know where I need to split. Go ahead and do it, right? Where can this go wrong, right? It can go wrong in a couple of ways. Like imagine that your model is going to retrieve the meaning of words and so on, and you split the data in a way that a part of a sentence is detached from the other part of the sentence, right? So maybe the actual meaning of the sentence wasn't very well like vectorized. It wasn't very well represented by the vectors that your embedding model created. Sentences split in the middle, or paragraphs split in the middle in a way that it becomes sort of strange to the embedding model. These can hurt the retrieval process because the meaning, the representation of those are not are not very useful, right? So this is where like your data becomes a little bit weird, and when you start to see that and start to play with splitting techniques, you notice how it's a big difference if you split it very clean and organized, like you have sentences and paragraphs and you
right.
see your data organized, and when the model is going to retrieve it and see it in the context, it's going to have that exact organized information, right? It understands the structure. There is a better overall accuracy in the model response because of that. And then you have other approaches like, okay, so what is the recursive character splitting? That's similar to a character base, but it's going to split multiple times into multiple characters, right? Separators. We call these separators. So basically, let's say I want to break my text into every new line, right? And
Right.
then after that, I want to split again into every period, right? And then into every semicolon, something like that. Okay, so this is the idea. This is a very used for code in general, right? For parsing and splitting code,
Oh, I
Python
can
code,
see that.
JavaScript.
Yeah, I can see why that
Yeah.
would be very useful in code. Got you. Okay.
Mm-hmm. Cool. And then we have semantic splitting, which is very hot right now. And one of my favorite approaches. I actually think it goes very well if you have semantic clustering together with a recursive or character based splitting, and this is what most libraries are applying. So let me try to explain like one. There are multiple ways that you can apply a semantic splitting technique, right? There are advanced clustering techniques, but the idea here is you are going to set an initial boundary so that you do micro splits, right? And then
Mm,
after those micro splits, you're going to extract their vectors, right? The meaning of those first chunks, and you're gonna merge them together if their meaning is very similar. It's very close, right?
right.
So let's suppose let me give you an example. I'm gonna try to use that ugly
I don't know.
drawing
You did great drawing
of
the last
mine.
time. I was really
You
impressed.
see, I'm ready, man. I'm up for the job. Okay, so look at this. Uh, if let's suppose we have like a couple of words, right? Let's suppose we have doing a live stream. Let's live stream together
Okay.
with David, right?
Okay.
So we have a couple words. Let's suppose that we have a sliding window over here that is going
Okay.
to take every two words and create a micro chunk, right? So doing a, right, and then a live stream, right? A live stream with David, right? And there you go. So for each one of these two overlapping chunks, we're gonna take a vector. We're gonna create a vector, right? So let's say this is the vector, like three little numbers. So we have these vectors over here, and I'm going to compare the vector of this first chunk with the vector of the second chunk. And I'm going to
Mm,
say, hey, you know what? The similarity between these two is very high. It's like 0.8, right? And then the similarity between these first and the next one is, I don't know, 0.7. And then suddenly one of them is like 0.1, right? It's very,
right.
very dissimilar. What implies that, well, maybe I'm getting into another section of the text as a whole, right? So this is the idea behind semantic splitting. You are creating small chunks, and you're regrouping them based on similarity, or even better, based on dissimilarity. You're finding the exceptions, right? The places where there is an outlier in the similarity between these chunks, right? And
Right.
then there are a couple of architectures that can be used to optimize this process, like clustering and different techniques where you're gonna set like a threshold, for example, over here to say, hey, you know what? If the similarity is below 0.5, I want it to split, right?
Right.
Something like that. If it's or maybe it's you're using something else like the standard deviation, right? If my standard deviation is higher than X or Y, I want this to be split over here, right? And that's
Right.
that's sort of the approach with semantic splitting. You are
Okay.
using the vector itself to decide, are these parts similar or not, like, and this works very well, right? If you first set, for example, with a component that we have today, you first set a character, like, let's say we choose a period, right? And then
Okay.
you're going to have sentences. So you're going to vectorize these sentences. Now you're going to check the similarity between these sentences one to another, and then when the similarity becomes very, very small, we split, right? And then you have like nice paragraphs, for example, being created. Oh, but isn't it easier to just do a rule-based stuff? Yes, of course it is. Like,
Right.
the problem is that data isn't always so well organized, right? When you extract data, a lot of times you're going to have entire documents without a single clear separation between what's a paragraph and another. Or maybe punctuation is not proper. Maybe you're
And there,
talking about informal data or comments, Twitter comments, right? So yeah, go
right.
ahead.
Right. And there are pros and cons, right? Like something like a character. I mean, each one of these, I think the way that you've laid it out here in the post, I don't know if I'm assuming maybe you did it this way on purpose, but it's like from the least complex, building on the complexity and potentially the processing time, right? A regular
Uh-huh.
just character-based split, right, on just period compared to doing a semantic split is generally going to be faster, right? Because the semantic
Yeah,
splitting,
absolutely. Yep.
you've got a model in there that now actually has to compare similarity, right, between each of these little pieces and see whether or not they're alike. So there's pros and cons there. Like if you, I guess my question for you then is like, I've actually used some semantic splitting. I actually think it's wonderful. It does a great job in a lot of the
Yeah.
cases of really kind of capturing like contextually relevant chunks and giving that to you. And depending on what I'm doing, I may really want that. Sometimes actually going back to the recursive character thing, like if I'm doing code, that makes more sense from that standpoint. But are there certain use
Yes.
cases, like, because semantic splitting is a little more, I mean, it costs more processing time, right? Like
Yep.
there's an added cost, or it's going to be slower. And especially if you're talking
Not only
about, like,
time and
huge,
money
is it
as
really
well,
just
right?
time? Is it really just time, and like the like cost benefit analysis of like how much time is taking compared to what you're trying to do, that kind of deal?
Yeah. So this is what I have in this blog about this. Sorry, not this. This over here. Balancing retrieval and
Oh, there you
ingestion
go.
costs. So this is a good, like, a very very smart question, and I think it comes down to how much you want to spend in your ingestion process, and how do you think about that is thinking how you're going to use this data, how frequently you're going to use that data, and if you just going to process it once, then the spending a lot of time in the ingestion is probably a good idea, right? Let me try to rephrase that.
Mm,
Sorry, I got confused. So let me try again. So you have your data, you're going to split it and vectorize it, right? A book. And then forever, like for the next 5 years, your project is going to have questions being sent that are going to retrieve answers over there, right?
okay.
There is always a cost to getting inaccurate, right? So
Right.
you need to balance out how much it's worth it to spend time in your ingestion process, and it's typically very very efficient to go through and just spend a lot of time and say, you know what, I'm gonna spend like some an entire week doing my ingestion, and I'm gonna do something very fancy and very nice if I have a lot of data even, right? You know why? Because this is going to be, there will be so many retrieval calls that it's worthwhile, right? so
Got you.
so I think this is the balance here. If you just have a single book, right, you're gonna ask a couple questions, you're prototyping. Oh my, why are you gonna spend a lot of time on splitting? First, start simple, right? There you go. So start simple is how, like, I would say for this kind of applications, you wanna start by experimenting. You wanna try out a lot of stuff. Again, we're talking about a model of development that wasn't out there a couple months or years ago, which is,
Right.
we have a big black box, and we're tuning the input to see outputs, right? So start very very simple, and you're gonna figure out what you want, and you're gonna understand the need. But depending on your retrieval cost, it's very worth it to spend a lot on the ingestion cost. I think that's sort of the balance you need to figure out.
Yeah, I think that's a really good point there.
Right?
I know in at least my own anecdotal experience, right? Like the way that you chunk and split your text and the way that you store it matters, right?
Yeah.
Like if you were to just store, let's pretend for a second, I'm just going to be absurd. If, we're talking about that book analogy. If imagine
Uh-huh.
then instead of storing things in big chunks of like sentences or paragraphs, you just stored things one word at a time and you vectorize every word, right? You're not
Yeah.
going to end up getting very relevant results a lot of the time, or if you do,
Yeah.
they're going to be so narrow. They're just not going to be relevant. You need to have some contextual knowledge that's stored in the chunks that you have, right? So there's
Yeah.
definitely a balance there. Now, no,
Yeah, and I think the best example to show like how expensive the splitting process can get is by using this last one here, which is the LLM
mm,
based, right,
yeah,
splitting. This would be basically prompting an LLM and saying, hey, my GPT, look at this text or look at this entire book, and you're gonna
oh,
have
right,
an LLM going through your entire book, right?
yeah,
And find like ideal sections for splitting and split it out for me, right? What this means is you are willing to spend LLM costs into running it through an entire book, because after that you're gonna have well chunks database, and you're gonna access that through retrieval so many times
yeah.
that the cost is worth it, right? This is sort of the idea.
Got you. Now, Rodrigo, I believe we
Yeah,
have you're going to show, like, I think we should see some examples, right? Like we've
yeah,
talked
I
a lot
agree.
about
I
it.
agree. I was gonna say that.
Okay, let's do it.
Let's go to the
Let's do something here.
chunkers thing, right? What you think?
Right. Yeah,
So this
so
is
everybody, just so you know, this tool here that Rodrigo has, this is actually built by one of my colleagues, Phil Nash, here on our DevRel team, our developer relations team. All it is, this is not meant to be like a production app or anything like that, but it is a way that is a tool that we built to help essentially folks understand what's going on here. So Rodrigo, I think you're going to take your blog, right? You're going to pop it in
yeah.
there, and then
Let's
we
do
can
this.
use this to kind of look at some of the different splitters and what they do. Um, and I know, so when I'm developing code and I am doing things, especially with RAG, obviously, I go right to this tool. I actually thought it was the coolest thing, because then when I am trying to figure out, like, actually a project I was just working on ended up being that semantic chunking was perfect for my case, right? Where in other cases I'd use like the recursive character, and things like that. So this tool kind of helps you kind of make some of those decisions. You can visualize what's going on.
Yeah, so I'm gonna try, and I'm also learning how to do this. So David is gonna we can try together. Let's see how it's going to work. I pasted the entire article over here, right?
Okay.
So I have it all together. And apparently when I copied from Medium, it didn't give me new lines, right? So let's see how that goes. Like 2 new lines. Let's see how that goes in the splitting. Maximum length, let's try to start very small just to see. And then minimum length is going to be 0, okay. Overlap size, I don't want to overlap, like maybe 10 characters just to see what happens. And then overlap, no, I don't want to overlap at all, I think. Okay. Split by sentence, not paragraph. Right. I think this tool, if I'm right, it's selecting the separators for us, right? We don't need to say to give it the separators. I think by sentence it's already splitting by a new line or by a period, right? So basically here, we have how many chunks? So 72 chunks. Is that it?
Yeah.
Okay, so basically we have a lot of chunks over here. In RAG, splitting text into chunks is key to making retrieval effective. But there's more than a da. All right. Okay, so I like
Doing
this
it at
actually.
the
So I
period
like this
essentially,
one.
right? It's
Yeah.
sentence based.
Yeah, and this is an example where the simple approach is
Or the
not very
terminator.
good, right?
Right.
It broke one of my sentences, right,
Right.
into
Right.
two, right? You see that? That's probably because there is a character here. Maybe it's a period. I don't know. Like basic character cuts. I don't know what is this. Let's see. Let's take a look at that. Like cuts to AI driven splits. Let me try to find this here. To AI.
There it is.
Let's you know. Oh, it's
Oh,
I
the
know why. I
dash.
know why.
Is it the dash?
You know why? I think it's because I added a maximum size. I have a maximum length here.
Ah,
Look.
right.
So that's why. So it split. It gave me that limitation. Okay, that makes sense. That makes sense. So I sort of created that hard rule, so we can't blame the system.
But what you're
Let's
doing here,
say,
this is
yeah, go ahead.
exactly the process, right? Because when you are
Exactly. Yeah,
using these
that's it.
types of splitters, you are setting these kind of parameters, right? If you're going beyond whatever defaults or whatever. So it's good to be able to visualize, like, oh, okay, if I make my length a little too small, depending on how I'm trying to chunk, that may not work for what I want, right? Or maybe it does. It depends, right? This is the whole point of this tool, is to give
Exactly.
you a way to visualize those things.
Yeah, and it's so important to visualize, right? In this kind of
Yeah.
process. Like I see so many people using just vanilla and default like tools, and they don't understand why the answers are not very good and so on, and
Right.
they don't have enough visibility into what's going on. And
Right.
this kind of application need visibility at all times. Like this is exploration at all points. This is one I don't like. Look at this. For instance, splitting every 10 characters or at every period, and
It's
then in
missing the
my
content,
article I
right?
added
Yeah.
a period, right?
Right.
It's not an end of a sentence. It's just the period found. So here's something that that maybe a language model splitting or the semantic splitting would make a better job, right? So
You
this
want to
is
try that
the
actually? Maybe
perfect
we should
example, I guess,
do
right?
the semantic splitting, see what it does in this case.
Yeah, I never used this one. Let's try. So maximum length. Uh,
It takes a second to process. There it goes.
okay, no worries. Similarity. Oh, it goes by similarity threshold. So the minimum similarity required for two sentences to be included in the same chunk. Okay, makes sense. It makes sense. So basically it's trying to. Oh, this one. The problem is this one is so big. Why is that? Let's see. Let's go over there and try. Am I moving my screen too fast? Let me know. Let's try 1,000. Right.
Okay. Give it a second to process.
No worries. So maximum length. Okay, this is the maximum length, but okay, I get it. So for example, I added here that I want a maximum length of 1,000, but it probably saw that this sentence is so dissimilar from this
Right.
one that
Right.
it wanted to separate it. And if I say no, but I wanted it to be together, maybe I should
You lower
decrease
the
my
threshold.
threshold.
Right. Let's
Let's
see.
see.
Here it goes. Oh
You
yeah.
see, like now
Yeah.
I just merged everything, but it works, right?
No,
So this is
and I
super
can
cool,
tell
like
you,
because it can, yeah,
doing something like this is a lot better to start off to get your feel for the data and how you might want to chunk it than just
yeah,
inserting this stuff over and over and over into a database, right? Into a vector store and just hoping for the best,
absolutely,
right? So you can use
absolutely,
it like this to
absolutely,
kind of like pare it down and go,
yeah,
yeah, these are the parameters I want to use. Let's go ahead and then start with
yeah.
that.
Yeah, and the good news is that exploring and trying splitting techniques and pre-processing techniques is almost free, right? You don't
Yeah.
need to explore with
Right.
your entire data. You can take one page of the book or 2 pages of the book and
Right.
do it, right? Let's suppose that you have huge amounts of data. Exploration is comes for free apart from the time that you spend. That again, I think it's worth it, right? We think it's worth it to spend time exploring enough before going into the vectorization process. And the vectorization is going to cost you. So if you go into the vectorization and then you come back to, yeah, let me try to improve my splitting technique, well, you spent money for free, right? For nothing, right? So you don't want it. You don't want it. So David, I have something to show you actually.
Oh,
So
what you got, man?
this is chunkers, right? Super cool. So for
Yeah.
people who want to access this, we should probably ping them the link.
Oh yeah,
It's
we
open,
dropped the link in there. Yeah.
but I do have LangFlow opened with a text splitter, right? So
Okay.
we can also export from here directly. What I'm doing here is look at that. I have the URL component, which is so basically the URL is grabbing the text from this link, right? This is my article again. So if I enter, I already ran it, right? I could run it again, but I already ran it. So if you come over here, you're gonna see the text, right? It extract the
Right.
entire text. Look at this. This is the text from the article
Okay.
coming directly from the HTML, right? So this is super like on purpose. This is super messy and like all
Right.
together. And we want to try splitting techniques over here. So this is the default split text component in LangFlow, right? If you
Okay.
come into the helpers section, you're gonna find it here. So split text, right? You
Okay.
drop it into your screen, and there you go, right? And you have a couple of parameters over here, like the chunk overlap, the chunk size, a separator, right? This is the character you want to separate, and I'm gonna show you like the thing working in real time here. Like first, I didn't use a separator at all, right? Or
Oh, so it
I
just
did. Sorry, I did a
oh,
space. I did a
oh, you did
space,
have a
right?
space. So
So
it's
let
essentially grabbing
yeah,
every word, right?
yeah. So I'm gonna do nothing first, right? So this is nothing, like no separators, meaning just every char is going to be split, right? So
Yeah, that
this is
would not be
terrible.
very
We don't.
useful, would
You never. Yeah, you never
because
go
you're
for that.
vectorizing every single one of those, right?
Kind
So
of it.
that's
Yeah.
right there. That's I think that's a point we should make sure that everybody here understands that when you're
Yeah.
chunking the text, you're going to vectorize every single chunk. So now imagine for every one of those characters, you're using the text embedding ADA02 model
Yeah.
from OpenAI with 1536 dimensions that you are going to now vectorize every single one of those into
Yeah.
1536 dimensions. Complete
Yeah.
overkill
That's a very
and,
good point.
and honestly pretty
Yeah.
useless, right? That's not going to help you at all in your RAG
Yeah.
pipeline or anything.
Exactly. So that's very good point. Like you want to balance the size of your chunk with the meaningfulness of it,
Yes.
the meaning
What's
of
got
it,
most
right?
meaning for
Okay.
you? What's got
So
most meaning for your
mm,
data? As a matter of
okay.
fact, real quick, Rodrigo, that actually goes to a
Yeah.
question from Zahara a while
Hmm.
ago. How does the splitting work with prompt engineering? Right. And I think part of it, Zahara and everybody, is like right there, the whole point of chunking and splitting through your text is to find meaning that you can give relevant bits of meaning to the LLM. So when you're talking about like prompt engineering and everything like that, and the way that you engineer your prompt and like how you want to engineer that, partially, at least in my experience, depends on the types of data you're putting in the context, right? And then
Yeah.
the way that you chunk them matters, because then that is actually what's going to end up in your context, right? So hopefully that kind of answers that to some degree, everything. But it just made me think of that particular question. All right, sorry, Rodrigo.
Yeah, very good, very good. Completely agree. So and then if you start trying these like different characters here, I'm using 0 and 0 for on purpose to show, right, for us to actually see. So this I'm splitting by every space. So you're gonna have words, right? Or over here you even see that you have words and some characters after it because it's not separated by space. So this is splitting by a space. Then now let's try to split by, for example, a period, right? And it starts making more sense. So you're gonna have like small little sentences that maybe you're gonna like, maybe not, right? For instance, splitting every 10 characters or every period found, again, that little problem we found over there. And you can start to dig into and be very creative with this. Like the first thing, you're gonna set the chunk size. So let's say I want a very big chunk size. Let's say I want a small chunk overlap. I don't know, just playing around. So too big of a chunk size. Sorry about that. Maybe we do 1,000, right? And 10. So you're gonna have a bigger chunks, and you can start to explore them through over here. You can see the entire thing if you click in length flow, like if you click every one
Right.
of them. And the nice thing here is this is pretty cool, David. Check this out. What you can do with, because length flow accepts like a pipeline of LLM and processing functions. So what you can do here is basically uh, I can link that into another text splitter, right? So let's say
Oh,
in
okay.
the first one, I want to do a period, right, with a chunk size of 1,000. Over
Okay.
here, I'm gonna do again, but for some reason, right, say my data wants me to do a comma, right? So I'm
Hmm.
gonna have the first splitting being split again into new chunks, right? So you're gonna have a sequential process that is going to split that, right?
Got
So
you.
so there you go.
Okay.
Okay.
Oh, that's very cool.
So
And again, right here at this point in Langflow,
yeah.
this isn't costing you anything, right? So
No,
you can
zero.
you can
Zero.
chunk
I'm
through
not
this. This
spending.
is
Yeah.
this is all
Yeah.
open source and that kind of deal. Or you can, even if you used it in our cloud service, DataStax Langflow, that even doing this is totally free, right? There's that's just part of the
Yeah.
normal cost. So you're not having to pay the cost with tokens and LLM or anything like that to do this process and experiment. And this way,
No.
well before you even inject anything into a prompt, pass it over to an LLM or anything, you can experiment with what works best and see how well your documents are being chunked.
Exactly. Exactly. That's exactly it. And where you start spending is when you add models to it, right? So let's say I have another one over here, which is the semantic splitter, right? Well, Rodrigo, but I don't see the semantic splitting in your sidebar, etc. We just built this, right? We built this 30 minutes ago just to demonstrate during this meeting. And I'm gonna show you how easy it is. Like this is why LangFlow is so powerful. LangFlow is Python, right? So creating a
Right.
component inside LangFlow is like it's a breeze, but there is a little bit of code I don't understand here. I know we have a bot, we have a chat bot that creates all of this for us. We just pass a Python function and it does everything, right? So it's super easy to create a component in LangFlow, and whatever
Right.
you add here to the code is going to appear over here in the screen, right? So we just created the semantic splitter, and you know what? I'm gonna David, right after this call, I'm gonna add this to the LangFlow store. So if you want to
Okay.
download the for free, everything in the store is for free, by the way. It's just called a store, right? So if you want
A
to download that
community store. I
component,
tend to
I'm
call
gonna,
it a community
yeah,
store.
yeah, exactly.
So yeah.
So if you even look for a split over here, I think there might be some folks that are creating like splitters. Look at this, like Markdown headers text splitter, right? By Victor. I don't know what this is exactly doing, but you can download it and you can throw it in your canvas and start playing with it and try to understand what's doing, right? So
Right.
so this is, so we can let's give it away, like give it in the store, and people who want to download, we can just look for semantic splitter over there. All right. So how this is working? Same thing that we discussed before. It's doing, this is using behind the scenes the LangChain approach. So it you can choose percentile, standard deviation, or interquartile, and when you run it, you have the number of chunks in total that you want, right? So
Mm,
I took the same data, right? This
okay.
is the article, and I
Okay.
said, hey, give me 10 chunks, right? And it gave me 10 chunks, but based on the semantic splitting that I
I
want,
got you.
right? So it's using that similarity, and it's breaking by like saying, well, I have a point of too much deviation, so I'm gonna break over here, right?
Got you.
And
Got you.
and that and there you go. So you can tune this, play with this. This is super fun to play with, and it's super easy. So use LangFlow. If you haven't, start LangFlow as well on GitHub, right? If you
You're gonna
if
drop
you
the
are
link?
over here in this live stream, yes, let's do this. Let's do this. So start us over here. It's one
Everyone
of the fastest
starring. It's
one of the
my terrible
fastest
song.
growing projects in the world today. So
Yeah.
don't forget to start us. It means a lot.
Okay,
And
so
then and
oh,
I have
go ahead.
another one, David, before we
All right, let's
before
do
we wrap
one
it up,
more, and
right?
then we've got some Q&A questions in our last 4 minutes. I want to be
Okay.
able to get to some of those, but let's see it. Let's see it.
This is super quick, right? I just want to show how you can build, like, very easily as well, how you can build your own splitter using a model. Like, this is the LLM-based approach. So
Ah,
URL. So can you see my screen?
yes.
URL, same thing, same text, right? This is our article, and then I'm passing the article, just parsing it a little bit, and then
Okay.
passing it to a prompt. And inside of this prompt, we have a instructions for the model to split it in a meaningful way, right? So
Got
here are
you.
the rules. You can come up with your own rules, but basically saying, hey, create chunks of approximately 1,000 to 1,000 to 1,500 characters and so on. And it's doing its job like very well. When you run it, you're gonna see it in the output. Like, it created the chunks based on the meaning that it found like
Mm,
most relevant. So chunk one, chunk two, chunk three, and there you go, right? And then, all right, in this case, I haven't actually split yet. This is just doing, like, it's just separating, right, and
right.
creating these chunks. What I could do here is now just pass a character text splitter and split by what, a new line, two new liners, or a regex to split here.
Right. I get you would chain it
That's
up, and
very,
then
very
you would
easy.
pull those out as your
Yeah,
chunks.
that's very easy.
Yeah, I
You
get
see?
you.
So I'm basically changing the text using the LLM, and then I'm taking those parts and actually splitting. So I'm using the LLM as a helper here to create meaningful chunks. And there you go. Like, this to me, like, if you have small content that will be retrieved a lot of times, it's probably the smartest approach, because the LLM knows very well where your text should be split much better than embedding models, even semantic chunking and so on. So yeah.
Cool. All right, with that, let's see. We've got some Q&A questions that I think are super relevant here.
Yes.
Let's find some fun ones. Now, one that we'll see here, Rodrigo, if you got something on this one from Charlie. Are there any courses on LangFlow that you would recommend?
Yeah. So, well, let's see. We have our YouTube channel, right?
Yep.
You should definitely check that out. Musba has created tons of videos for you over there. Make sure to go through our docs as well. So we have a couple of examples over there. But if you go to YouTube literally and just write Langflow, you're gonna find a lot of tutorials from folks around the globe. Now, if you have specific applications or something that you need help as well, reach out, like, send us an email. We're happy to help everyone. We have the Discord channel, and let me actually show you our GitHub channel here, David. So I'm gonna actually send the link. It's gonna be better. I'm
Oh,
gonna
I,
send
I
the link
dropped the
for
link.
our
Yeah, you go
GitHub
ahead and
channel.
get the link, and then
Okay, great,
while you're
great,
doing
great.
that, I'm gonna get another question here. Ryan
Okay.
asked earlier when we were talking about like using LangFlow and such. Let me pop it up here. So would I drop this into something like Pinecone, or does this replace a need for Pinecone? LangFlow is a database or just a tool to get vector data?
It's
LangFlow is,
so
yeah, go ahead, Rodrigo. Yeah, go on.
Okay, Langflow has the building blocks, and you can connect Pinecone after you split, right?
Yeah,
Langflow integrates with
a
dozens
bunch of
of
different
vector
vector
stores.
stores. Yeah,
Yeah,
dozens. Or
so
yeah,
Pinecone, Vectara, Weavy A3, and we
After
have obviously
Chroma,
Astra
yeah,
DB, yeah, which is DataStax's native vector store, right?
right.
So there is a very cool integration with it in the cloud version of Langflow, right? But you can choose your vector store from the sidebar. There's a session called vector stores, right? So you look at that and you do the ingestion. If you want an example for the ingestion in the beginner, like starter projects, there are some examples, and one of them is the the Q&A, right? The Q&A has ingestion for RAG and retrieval. So both in the same flow so that you can understand what's going on over there.
Okay, okay, awesome. This one's an interesting one from Brian. Our RAG uses 30 different books when users query the RAG. Sometimes it gets confused and pulls from the wrong book. We tried using metadata to create a clear subject for each book. Is there a better way to do this? Or is there a way to let them select which book they want to pull data from?
That's very good question.
Yeah.
Like this is the kind of problem that people are still solving and that I have a strong opinion on. Not necessarily the best approach, right? But how I see this is exactly like we discussed before, David. You wanna emulate the human behavior here, in my opinion. You wanna go and say, well, let me do a hierarchical search. So instead of vectorizing the books, everything inside the books, and just asking directly, like this is what a lot of approaches do, right? What they're going to do is they're going to take the 30 books and they're going to vectorize everything together. And like by everything together, I mean just separate into chunks, right?
Right, right.
How can you have your model getting the proper book before it tries to retrieve chunks? What you can do is you can create summaries, for example, of the books and create like vectors of those summaries, right? So imagine you have a first layer of retrieval, right? That first layer is going to find what book to search for that question, right? So
Mhm.
you're gonna have for example, for the 30 books, you're going to have 30 summaries, right? Summaries, very small summaries, for example, with meaningful descriptions of what those books contain, right? And then your search is going to, like, maybe you're going to have even a model approach, maybe not even retrieval, like maybe a model just choosing between these. And then once you filter which book to choose, you're going to have the vector being searched with the search being performed with metadata to exclude books that should not be searched.
Oh,
Does that
interesting.
make sense, David?
Yes, yes. And I almost wonder too, Rodrigo, if this potentially would be a case for a graph rag kind of neat, because
Yes. It,
then
it,
instead of,
it is
you're
a
not just
subset.
relying on the
Yeah.
chunks at that point, right? You're relying on like either keywords or certain phrases or links or something that you can relate between various books. So it's not just like, to your point earlier, you're not just taking all of the data from all 30 books or whatever it is and just chunking that and then going off of that. You're still doing that portion, but you're getting this extra piece where you're looking for maybe keywords or other things that can relate various items. So then when you do a search, you're not just finding that one chunk. You're actually pulling back maybe a set of chunks and then related items or something like that. I kind of wonder if that might be
Yeah,
possible.
and I think that's a generalization of the hierarchical approach. If you take hierarchical search, is basically one of the forms of graph rag, right?
Got you.
Uh,
Yeah.
so
Okay.
so
That's
a
what made me
hundred
think of that
percent,
when you
a
said it.
hundred
So
percent. No, 100%. Like, and even like when I saw GraphRag for the first time, I wondered, is that what I thought would make more sense? And then I understood how GraphRag is even more like generalizable and better and like more powerful than this hierarchical approach. But for this case, like this simple case of 30 books have metadata on these books. Well, let's vectorize this metadata. Let's try to extract meaning from the titles and the summaries and so on of the books before I start digging into like multiple layers, right?
right. Yeah, no, exactly. And I see some comments there in the chat that it looks like Brian says, "Thank you so much. I never thought of doing it that way." So maybe hopefully there was a useful nugget there that you can use. Exactly. Now we are over time. I want to be respectful of that for everybody. And with that, I think we should wrap it up. Rodrigo, you have any last words? Anything else that you wanted to impart to folks? I feel like we
Yeah,
gave
yeah, yeah.
we went over a lot of stuff today, actually.
Yeah, so really cool, really cool. And thank you everyone. We have over 100 people online right now. So thanks everyone for joining. We're working hard on building something very powerful and easy to build with LangFlow,
Yeah,
right? The idea behind LangFlow is how can I connect models and APIs and external tools all together and models with other models, and how can I
right,
do that in a interactive way, right? Because back to the black box theory, right? Traditional development come to, hey, I have a problem, I have a bug, let me look into my function and let me fix what that function is doing, or let me change what that function is doing. AI development is like this. You have this big black box in the middle, and you don't have control of that black box. You have control of the inputs,
right.
and you see the outputs. So you need visibility at all times, right? That and for that, AI sort of begs for a new kind of IDE, a new kind of development system that gives you a lot of control and visibility and interaction. That's what Langflow is for, and we hope to get this. Like, it's completely free for everyone, open source. So join the community, join the Discord channel, and let's build together. Thanks, everyone.
Awesome. Thank you, everybody. Thank you, Rodrigo. And we'll see y'all next time. Take care.